Hello, grade 12, welcome back. So now we are looking at question 10, and this is a probability question, okay? So what is it that you're given here? 10.1. So they are saying to us, A and B are two independent events such that the probability of A is equal to 0.2 and the probability of not B is equal to 0.45. And 10.1.1, what does it say? Determine the probability of B, right? So how are you going to go about solving that question? Now, let me write here. Okay, so probability question, right? And this is one of the difficult we faced with. Okay, so 10.1.1, what is it that we are told then? We are told that we must find the probability of B, right? And one thing that we have seen is um, they give us the probability of not B, which is 0.45. Okay, so probability of not B is equal to 0.45. We are going to use this probability of not B to find the probability of B. In what sense? We know that the probability of not B is equal to 1. Okay, this is how it is. Probability of event A plus the probability of not event B is always equal to 1, right? So if that's how it is, then we want the probability of B. So it means the probability of B plus the probability of not B. Not B, you see, this one does written as not B. You can also write it in this way that I've put it here. So you're going to have plus 0.45, and this is equals to 1, right? So the probability of B will be equal to 1 minus 0. The probability of B will therefore be equal to, what is 1 minus 0.45? 1 minus 0.45 is equals to 0.55. Okay, so that's how it is. So this is 0.55. And moving on, what is it that we are given on the next part? Let's see. Okay, yeah. So you're not saying we must find the probability of A or B. Okay, we must find the probability of A or B. So probability of A, probability of A or B. Okay, we know the probability of A or B is equals to probability of A plus probability of B minus probability of A and B, right? This is what you know. So probability of A or B is equal to probability of A plus probability of B to B. Remember, let's just verify. Yes, it's 0.2. And what is the probability of B? The probability of B, we were not given the probability of, we did find the probability of B to be 0.55, right? To be 0.55. And it's so important that these two events are mutually exclusive. So this one here is 0. Did they say that these two events are mutually exclusive? Let's see. A and B are two independent events. So you see that these two events are independent, then it means we have to find the probability of A and B. Probability of A and B, right? Two independent events, what do? We know the probability of A multiplied by probability of B, right? It's going to like we get probability of A and B through multiplication. And when they say independent events, that's what it means. So find the probability of A and B, right? So this is 0.2 multiplied by 0.55. So what is 0.2 multiplied by 0.55? Let's see. 0.2 multiplied by 0.55. This is 0.11. Okay, 0.11. So it means I'm just going to have 0.11. And my final answer would be what? 0.2 plus 0.55 minus 0.11. This is 0.64. So you see, it's a very, very tricky question. So please take care of such terms. Independent, it is found through the multiplication rule. So this is the multiplication rule of probability, and this is the addition rule of probability. So that is it with the 10.1.2. Now you're looking at 10.2. So with probability, you have to understand the statement and be able to solve questions using the tree diagram technique. Okay, and this is one thing that I've just seen with this question here. What does it say? It says Asanda travels to school on her bike or by taxi, right? The probability that she travels by taxi is X. Okay, so you are being given information that you're supposed to take down there. Okay, so 10.2. Okay, now I said it's very, very important that you familiarize yourself with using a tree diagram. So let me just start my scenario here. Okay, so they're talking about Asanda using a bike or using a taxi, right? So this is what we are being told there, and they're saying that Asanda travels to school on a bike by Asana travels to school on a bike or by taxi, right? The probability that she travels by taxi is X, okay? So if the probability that she travels to school by taxi is X, what would be the probability of her travel by taxi? You should know that the probability in each and every branch, right? You see, this is a branch one, right? So it means if you want to get one here, this one what? 1 minus X, okay? So that's how it is. Now let's hear what they say. Then they say the probability that she travels by taxi is X. Oh yeah, the probability that she travels by taxi is X. So I made a mistake. Let me go back to my tree diagram there. Made a mistake. This is not supposed to be like this. This is X, and then this is going to be 1 minus X. The probability that she travels by bike is X. Okay. And then what is it that they said? Now, if she uses her bike, the probability that she will be late for school is 1. Okay. This is the conditional probability. She used the bike, right? This is her using the bike. If she uses a bike, they're talking about the probability of her being late, right? She becomes late if she has used the bike. And what is the probability of her becoming late when she used the bike? Probability that she used the bike, it's what? Let's go back. If she uses a bike, the probability that she will be late for school is 2/5. Okay, so this is gonna be 2/5. Her bike. What is going to be the probability of her not being late? The probability late, provided that she used the bike, right? It's gonna be supposed to give us 1. So to get the other one is supposed to say 1 minus 2/5. Okay. So and this is gonna be what? This is gonna be 3/5. Okay. Let's find out what's next. Okay. Then they say the probability that, and if she travels by taxi, the probability that she'll be late is 1/2. Okay. She becomes late when she's used a taxi, and that probability is 1/2, right? What is going to be the probability of her not being late? Not being late, I put N and the slash on top of the N, right? And it's also going to be 1/2 because probabilities in each and every branch, they always give us a sum of 1, right? So going to be our outcomes here. Okay, we are going to have our outcomes here. We are going to have what? We are going to have what? Bike, and we get that by multiplication. The probability of bike and not being late, right? And then here we're going to have the probability of taxi and being late, okay? And then you're going to have the probability of taxi and not being late, okay? So this is something that we are supposed to take care of. So those are the outcome of the event that you're having in this program. So let's see, what is it that they said again? Then they said, determine the value of X if the probability that Asana is not late for school is 8/5, okay? So they're telling us that the probability that Asana, okay, is not late is 8/5. The probability that Asana is not late at all is 8/5. So what is the probability of Asana not being late if we compute it from the tree diagram, okay? The probability of not being late. So let's compute it from the tree diagram. Probability of not being late, right? So you see, this is what? Probability of not being late, that she used a taxi. What is it? It is 1/2. So I'm going to say probability of not being late, provided that she used the taxi, right? Multiplied by X, right? And then plus what? The probability of not being late, provided that she used a bike, right? And that is let me just confirm what is it that we have there. Going back, probability of not being late. This is one, not being late, provided that, so it's going to be 3/5. We're going to have 3/5 multiplied by 1 minus X, right? So this is what we have. And we already have the total probability of not being late. So it means we can be able to solve it when it is like this, right? So, and we know that this is what this is 3/5, 1 minus X is equals to 8/5. Okay, so 1/2X plus 3/5. Okay, then this one minus 3/5X is equal to 8/5. Okay, so this is what we have. And then 1/2 minus 3/5. This is what? This is negative 1/10x, right? And then I take this one across to say 8/5 minus 3/5. So what am I going to have there? Let's see. 8/5 minus 8/5 minus 3/5. 8/5 minus 3/5. It so happened that the answer is 1. Oh, there's a problem here. As you can see, we have 1. There's a problem. So here, it so happened that x is going to be what? 1 divided by, it can't be negative. There's a problem. 1 divided by negative 1/10. There's a problem. I'm not sure what is the problem. We just have to review our calculation and check where did we make a mistake. X is saying it's 10. We have a problem here. So let's go back to a statement. Maybe there's something that we missed out, or maybe there's somewhere we made a mistake. Let's check. 2/5, and there's something that I have 3/5. I'm not sure where did I get that 3/5. Let me check. Where did I get 3? I think this is a mistake that I made. 2/5 here. It shouldn't be 3/5. So let me just go back to the tree diagram. Yeah, let me just go back to the tree diagram. I think that's the mistake that I made. So on the tree diagram, oh, okay. Wait, let's see. 1 minus 2/5, and that is 3/5. So where lies my mistake? Where lies my mistake? Let's see. I'm not sure where did I make a mistake? Because as you can see here, what is it that we have? We have 1/2 multiplied by x. Like they're saying the probability of not being late at all, right? So the probability of not being late, they give us as 8/5. And we said the probability of not being late required that the text is 1/2 multiplied by x. Okay, and the probability of not being late, let's see, maybe that's where I might have made a mistake. Probability of not being late, the way that she used brackets. 1 minus x. Okay, now let's see where did we go wrong, because we can't be getting wrong things if what you are doing is correct. Oh, I'm going very, very far now. Looks like I'm going very, very far. Let me check the question. Maybe we interpret it well. As Sandra travels to school on a bike or by taxi, the probability that she travels by taxi is x. If she uses a bike, the probability that she will be late for school is 2/5. And if she travels by taxi, the probability that she will be late is 1/2. Determine that the value of x is the probability that Asanda is not late for school is 8/. Oh, you see where the problem lies. It's 8/15, not 8/5. That is where the problem lies. The problem lies here. The problem lies here. It's 8/15, not 8/5. So that's where the problem lies. 8/15, not 8/5. So one thing that you should know is when you're writing, please check your calculation, because mistakes are common. I won't lie. We are human beings. We are prone to making mistakes. Okay. So 8/15 minus 3/5. You see, now it is making sense. So I'm going to have negative 1/10x is equal to negative 1/15. So please check your calculations. We are human beings. We make mistakes. Okay. So then x will be equal to. I'm dropping the negatives. I'm going to do it because negatives. I'm dropping negatives from 1/15 divided by 1/10. Okay. So that is going to be my x. So x will be equal to 1/15 divided by 1/10. That is 2/3. So x is equal to 2/3. So that is how you will have went about solving this question. So you've seen that I'm even being army. I do make mistakes. So just make sure you don't make those mistakes. You check your calculations. Okay. So that will be it for now. See you on the next